A very good morning, student. Let's see the information about the molecular spectroscopy. See, molecular spectroscopy is the spectroscopy which gives us the information about the structure of the particular molecule. And generally, under the molecular spectroscopy, we studied some important types of spectroscopy. So, out of which one of the important topics, that is infrared or vibrational spectroscopy, we are going to study in this particular lecture. So we know very well that vibrational spectroscopy gives us the information about the vibrations of the molecules. It means in the particular region of electromagnetic wave, when the vibration of the molecule takes place, then the vibration can be of any kind. From that vibration, we can identify the particular molecule, or we can identify the characteristics of a particular molecule. That is why vibrational spectroscopy or IR spectroscopy is very important. So let's continue today's topic. It is defined that the study of interaction of electromagnetic radiation and a matter. So what is a spectroscopy? The definition of spectroscopy is given over here. Due to interaction, the incident of absorption or emission of electromagnetic radiation by the molecule happens. Output of the interaction provides the data like frequency or wavelength of a radiation and the intensity of radiation emitted or absorbed by the molecule. In this way, we can determine the size, shape, flexibility, electromagnetic arrangement of the molecule. Means molecule structure can be studied easily. So here is a diagrammatic representation which gives us the overall idea of the spectroscopy. So even in this particular diagram, we can get the overall idea how the spectroscopy works, or different regions of electromagnetic radiation. So as we discussed that when we talk about the spectroscopy, there are various types, or there are various sub-spectroscopy which come under the term spectroscopy. Some important types of spectroscopies are given over here, and these are types of microwave spectroscopy, infrared spectroscopy, another is a Raman spectroscopy, electronic spectroscopy, NMR spectroscopy, or which is also known as ESR spectroscopy, X-ray mass spectroscopy, electron microscopy. So all these are the types of spectroscopy. So let us see the applications. So what are the application, or what is application of spectroscopy is given here in short. Depending upon the frequency range, these spectroscopies are classified. Each class of spectroscopy has its unique set of application, whether it is the field of physics, chemistry, biology, electronics, or biochemistry, and other fields also. Next, the main characteristics of electromagnetic radiation. So a simple information about electromagnetic radiation, or the way of finding the energy, is given here, which says that E is equal to h mu. And what is h? H is nothing but the Planck's constant. In the next, The next slide tells us about the relation between or the information about what is wavelength, what is frequency, and what is the energy of radiation. So the distance between crest and trough is nothing but the wavelength, and the wavelength is denoted by the Greek letter lambda. Wavelength is always used in meter or in centimeter. Then in a particular time, how many time of repetition of crest or trough takes place, that is known as its frequency, and due to the frequency the energy is generated, the energy is carried out. The electromagnetic radiations can be two types. It can be absorption type or it can be emission type. So let's come to our main topic, which is infrared spectroscopy or which vibrational spectroscopy. There are various types of vibrations. Okay, when the energy is observed in the particular region, what happens, the vibrations of the molecule takes place, and these vibrations can be of different types. So on the basis of types of vibration, we can find out the characteristics of a particular molecule. Next, the important formula regarding the vibrational spectroscopy is given over here. So these formulas we'll see in detail in further classes. Let's see this particular diagram. This particular diagram is very important, and over here this is nothing but the 0 point energy, and according to 0 point energy, it is said that at the zero level, even at the zero level, the energy is never zero. Then afterwards we have selection rules, some important diagrams, some peaks which are taken with the help of the spectroscopy. So this is another important expression, and this expression will give enough information about the structure of the atom. So this is the information about the spectroscopy, or this is the information about the vibrational spectroscopy of the molecule. So here we will stop, or here we will end our today's lecture. Thank you very much.